of terms in GP. Example, find the value of n given that the nth term of a GP is 2916 and the first term and common ratio are 4 and 3 respectively. If you want to look at this, we have the first term is a, which is equals to 4. We have been given first term is 4 and the common ratio is 3. Our r is equals to 3 and the nth term is equals to ar raised to power n minus 1. And beside, you are also been given the nth term here. What's the nth term here? Is also 2916. Now you can realize that the nth term here are the same thing. So you now have 2916 will be equals to your ar raised to power n minus 1. So 2916 equals to your a is 4. So you have 4 here and your r is 3. So you have 3 raised to power n minus 1. So we continue here. The first thing we have to do is just like we have to divide by 4, divide by 4. So this one we cancel this. So this one give you the 729, which is equals to 3 raised to power n minus 1. So, and we can now split our 729 now, so that it has the same base as 3 here. So you have 729 now. This is 3, goes there 2, remainder 1. In 12, you have 4. In 9, you have 3. 3 again, you have 81. You have 3 again, you have 27. 3 again in 27, you have 9. 3, you have 3, you have 3. So the knowledge of your indices means that here you have 1, 2, 3, 4, 5, 6. So you have 3 raised to power 6 is equals to 3 raised to power n minus 1. So the 3 cancel 3, you have 6 equals to n minus 1. So your final answer is that your n is equals to 6 plus 1, which is equals to 7. Remember your knowledge of indices. You make them to be of the same base for you to be able to cancel it out. Now let us look at the example 2. Find the common ratio of an exponential sequence whose 10th term is minus 512 and the first term is 1. Now, exponential sequence is the same thing as geometrical progression. And we have been given that the 10th term is that. We know that this is the nth term. Nth term is this. A raised by n minus 1. So the 10th term means n is equals to 10. So we now have 10th term is equals to a raised to power 10 minus 1 rather. So we have 9. So in this case also, we have been given that the 10th term is equals to minus 512. So now this is our 10th term, this is also our 10th term. So we'll say that minus 512 is equals to AR raised to power of 9. Of course, we know that our first term here we have been told, look at this, first term is 1. So our A is equals to 1. So we are putting the first term here. So we have minus 512 is equals to 1 times R raised to power 9. So we continue in this way. So we have minus 512 is equals to R raised to power 9. Now we are to get the common ratio, meaning that we are going to get the 9th root of minus 512. So we will have R is equals to the ninth root rather, the ninth root of 512 minus 512. We'll now say that our R, the R is equals to minus 2. Once the R is equals to minus 2, and that is exactly what they ask us to find. So we move on to the next. Looking at example 3, find the first term of an exponential sequence whose seventh term is 4096 and the common ratio is 4. We are asked to find the first term. So if we must get the first term of this, let's start with this, the solution. Find the first term. A is what we are looking for. Seventh term is this. Seventh term is equals to seventh term equals to this. So that is 4096. The same seventh term, according to what we have done before, is AR raised to power 7 minus 1, 6. So this one and this one, they are the same thing, and we are also be given that R is equals to 4. So we put everything, since this one and this one are the same thing, so we have 4096 is equals to AR raised to power 6. You have 4096 is equals to, the A is the one we're looking for, times 4 raised to power 6. We get it. So at the end of the day, we will now find the value of 4096. 4 raised to power 6, can use calculator for that. 4096. So we have 4096. So we divide everything by 4096, 4096. So our A now is equals to 1. So we get our A to be equals to